Okay. I think we can start.
Okay.
Just 1 minute. Okay. Okay. I wish you good luck. Bol şans diliyorum. Teşekkür ederim geldiğin için.
Oh, that's too much. I know iyi şanslar.
Okay.
And it will be a lot.
Yes, good luck. Okay.
Thanks a lot. Hi, everybody. Thanks to be here for this talk about from imperative to reactive. And since it's not in Kotlin, I won't show you coroutines, but in the demo repository, you will have the Kotlin branch, so you can see how you can get further. I'm Nicolas Frankel. I've been a developer for a long time. I still think that I'm a developer. Even most of the time, I don't write so much code. I'm now a developer advocate. And more importantly, I'm not a reactive guru. So what I want to show you today is the exact steps I went through when I tried to learn reactive programming myself. It doesn't come from above, it comes from just from the ground up. I work for a company called Hazelcast. You might have heard about Hazelcast because I already talked about Hazelcast in the previous Jug and also in the previous Java Istanbul. So I won't go further again. Let's just focus on reactive. And reactive is actually, well, depending on your perspective, might be old or not that old, but it's already like 7 years ago. And it started with the Reactive Manifesto. And the Reactive Manifesto states 4 properties of a system to be considered reactive. So the first one is it must be responsive. And when you send a query or request, it responds nearly immediately. It's resilient. So whatever pieces fails, it must still do something, even if it may fail gracefully, but emphasis on gracefully. It's elastic, meaning that it scales, perhaps not linearly, but quite close to linearly. And finally, it's message driven. So you don't just only call and expect an answer or response right away. You just do something, and sometimes in the future you expect the response. And when the Reactive Manifesto was actually written, the authors had the actor model in mind. And the actor model comes from the Bean platform with Erlang. And the idea behind the actor model is you've got like several actors that communicate through message passing. Each actor has a message to you, can send it message, and then it can handle them. And on the Bean platform, the good thing is that the actors, when they just die, they get restarted automatically. And in the end, it went not that way, because right now, the most popular programming model is not the actor model, it's the reactive strings. And there is a page about that. And the idea is still to do non-blocking message passing asynchronous stuff, but in a completely different way. The idea is to do it through the event loop. So you've got requests that get queued into an event queue, and then you've got an event loop that handle them and dispatch them to the right place. And you might ask yourself, why should we do reactive? Well, there is one good reason and not that great reason. So let's talk about the not so great reason. You might say, hey, but I want to be reactive because I want to scale. And that's correct. That's technically correct. Like in non-reactive system, you probably would have 1 request per thread. And so far on the JVM, the threads, they are mapped to like system threads, and there is a hard limit on them. And so your system cannot scale indefinitely. But to be really honest, until you reach that point, you've got a lot of buffer. In general, you don't go reactive when you've got like 10, perhaps let's say 1,000, 10,000 concurrent users, you can still handle it. And most systems, they don't handle 10,000 concurrent users. So you must be Google, Amazon, whatever, to really have this kind of requirements, or Twitter, or those kind of companies. Now, another reason why you might want to get reactive, and it might make sense, is that it's more cloud friendly, meaning that you're really using all the power, all the CPUs of your machines. And if you are on the cloud, that means that you only pay the minimum, which is quite good, because when you are running on-premise, you can waste CPU cycles, you don't care. It might cost a bit more electricity, but electricity is cheap. Like in most countries, it's super cheap. When you run on the cloud, however, then it will be billed and it might amount. And depending on your use case, you might have huge savings or small savings. Now, everything is a trade-off. So on one side, you might like not waste money, and you might save some money on your capacity, on your CPU and RAM capacity, but of course there are downsides like in everything. The first thing for your developers, it's a more complex mental model. When you are doing reactive, when you call an API, you're not just calling the API and receiving the answer, you're just like subscribing. We'll see just that afterwards. And so the way to look at things is completely different from an imperative point of view than from a reactive point of view. Then, because of there is not one single thread that will execute the same requests, the code might switch from thread to thread, so that it will be much harder to debug when there is an issue. You won't have thread local, of course. And what I really felt myself, the biggest issue was that you must learn specific APIs, and you have different providers of reactive APIs, and of course they are closely related to one another, but still they still have their own flavor with slightly different semantics. So that was for me the hardest part. So in general, when I know what I want to do, I just ask my friend, Reactive Guru, hey, how can I do that? And he answers me. But you need to learn those things by yourself. And about reactive, you've got the whole code chain, and everything needs to be reactive in the chain. As soon as in between you've got a blocking code, then your chain becomes blocking again. That's not really what you want. Then you will lose many of the benefits that I've told before. Regarding the API, here is the Reactive Strings API, and you can see it's only 4 classes. Those are the foundations of every other API. On one side, you've got the publisher, and the publisher, you can subscribe to a subscriber. Then you've got the subscriber, and you can do something when you subscribe, when you receive the next element, when there is an error, or when you finish successfully. Then here you pass in the subscription. You can see that the subscription can request more elements, and here you've got the back pressure here, because you say that's the subscriber that tells, hey, I want X elements because I know I can manage them, or it can cancel, it can stop subscribing. And because we want to do a chain, then there is the processor that is both a publisher and a subscriber. And those are pretty simple, actually. Now we've got other frameworks that build upon them. For example, there is Project Reactor, which is one of the reactive strings implementation. It's led by Pivotal. Now it might be set VMware or Tanzu. To be honest, I don't follow the reorganization. Important stuff, it's not dependent on Spring. Spring is dependent on it. That's completely different. And you can see that it implements the publisher. For example, in Reactor, you've got like the 2 foundation classes are mono, and flux. Mono can contain one or more elements, and flux can contain like any collection of elements. It's an unbounded stream, and both implement publisher. You might have heard in the JDK there is something called the flow class, and actually the flow class also implements those 4 interfaces that I've shown just before. And when you go on the Reactive Strings website, they tell you, hey, no worries. Right now we are using Reactive Stream in the package Reactive Streams, but soon we will use the JDK 9 classes. Well, it was written in 2017. 4 years later, they are still using their own package. So if you want to bridge between them, you need to use something called flow adapters that exist in the Reactive String library. Now let's talk about Spring. Spring Web, since version 5, allows you to use reactive types. And there is a dedicated dependency for that called Spring Web Flux with a dedicated package. So let's see how they compare to each other. There is Spring MVC on one side, Spring Web Flux on the other side. Can they be configured with annotations? Yes, in both cases. And can you configure them through APIs? Yes, in both cases. So what you think in general would be, hey, that's not an issue. I have my Spring MVC project here, and I will just keep the annotations, and then I will migrate to Spring Web Flux. It's a direct change. And why it will probably work in the short term, you might have a lot of issues, because now your annotations, they won't be processed by Spring MVC, they will be processed by Spring Web Flux. So the whole mechanism underneath will be completely changed. And so your familiarity with the framework will just be familiarity with the annotations that are just like annotations. So what I will do in this demo is I will start from Spring MVC annotations. I will move to the API, and then I will move to Spring Web Flux, so that at least you will understand it's a completely different world. But again, if you already know about Spring Web Flux, you are familiar with annotations, and you want not to change your project too much, you can just go directly and use the annotations and just change the underlying engine. But again, I wouldn't suggest you do that. So now it's time for some demo. Oh, I missed the most important slides. Hello. And now we must do some demo. So here I've created a project. It's a simple, very simple project. As you can see, I've integrated the latest Spring Boot starter, and I have Spring Boot Data JPA. I have Spring Boot Web. I am using Hibernate. So since I'm using Hibernate, I want to do some caching, so second level caching. And that's not really useful because I'm using an in-memory database, but it's still to show you, because during the demo, at some point you will see that I'm losing the cache and I need to bring it back again. So I think it's an important problem. So I have this application. I was using start.spring.io, so it should come as no surprise. I have this like application class, then I have a controller. Controller has 2 endpoints. You can query a person, all persons, or you can query a person by their ID, one by one. And then I have the repository, and because I'm using Spring Data JPA, I don't need to write anything. It will be created by Spring. And of course, I have the person, which is a stupid entity like always. I mean, I always use the same example. And at the beginning of the application, I will like automatically populate the database with some dummy values. So let's start this. Let's start this application, and now comes the first. So if I have an issue at this step, it will be really, really bad. So fortunately, I don't have an issue at this step. So the application has started. I have enabled the Hibernate Analytics just to show you how the cache works. So here it just started, they are empty. And I will curl, let's say, the first entity, and it tells me, it returns me the one that I created. And we can see that there was one miss and one put. And if we redo it again, well, amazing, it still works, and we still have one hit, so it's read from the cache. Perfect, nothing mind-blowing. So that's the base of our application. The next step would be, hey, now we want to move to Spring WebMVC, but the functional way. We want to remove the annotations from the controller. We want to remove REST controller and get mapping, and we want to do routing in a functional way, so it's explicit and not implicit. So let's do it. And I won't do any live coding because it's even more risky, but I have everything on Git, and afterwards you can check it by yourself. So now what I changed is that I still have annotations, but they don't mean the same thing. Here, now I have a configuration class and I have beans. And in those beans, I create a router function. And the router function actually would take a server request and return a server response. So here I have the server request and it returns the server response. So here you can see that I explicitly call, hey, return HTTP code 200 with the body of this. And here the same, and just pass in the ID. So you might think that it's not big change because I still am using annotations, but actually here I'm explicitly telling what I should do in a functional way. And it still works. The next step is actually to move this code, this code into a dedicated handler class. So that's what the Spring team proposes, that we should move them to a dedicated class. It doesn't change a lot. It's just that it makes your code decoupled. So on one side, you've got the routes, which are now much easier to understand. Hey, when I get person, I will do this. When I get person/ID, I will do that. Then you've got these person handler codes. So you inject the person repository and it's still the same code as before. Let's check that it still works. So it still works. We still have the cache. Yes, we have the put. Perfect. We do the same. And we have the hit. Perfect. That seems to be pretty good. Now what we can do is, instead of having different functions that return different beans of router function and they will be merged by Spring, we can regroup the ones that are tied together. Here they are tied together. One is about returning all person, the other is about returning one person. We can merge the routers together and it looks like this. So I have the same stuff as before, but I have nested. So here I say, hey, the root is /person, and then when I get slash, I return, I call the handler.get all, and when I get /ID, I return the get one. It still should be working. It's still working, and we can see that now the cache is used as well. And at this point, it's important to take a step back and to understand that we are still using Spring WebMVC, just in a functional way, but nothing reactive at this point. If you are if you prefer to do some functional programming and you dislike Spring, perhaps it should be a good start. If everybody among your team is using Spring, perhaps you can start by trying to move them away from the add controller and add mapping and move them toward this more functional part. The next step is actually we start by like going reactive and replacing Spring WebMVC by Spring Web Flux. And because all the work we did before, it's actually like that simple. Here, sorry, I don't know why it's open in the other window. So here, there is one change in the POM. We replace starter web by starter web flux. On our roots, we just changed the package name. Actually, the classes themselves, their simple name is exactly the same. They are just in another package. So rata function moves from org.springframework.web.server.function to org.springframework.web.reactive.function.server. It's the exact same stuff. There is another change, is now we are returning not the response itself, but again, a wrapper around it so that it can be subscribed to and it can provide some value when the time is right. So now we wrap our server response in a mono, and here as well. There is a slight change because now if you use body here, it means that this is a reactive type. And since it's not a reactive type yet, we will go to this. We must tell it, hey, we must return this exact value. So we shouldn't subscribe to it, it's just a regular value. And normally I should have restarted, and if I do it again now, it still works. Yes, no, yes, it still works. I had the hit. So that seems to be pretty good. But if you remember what I told you before, that if one part of your code chain is not reactive, then the whole chain is not reactive. And what we have right now is we have part of our code chain that is reactive. All the WebMVC has been replaced with Web Flux, but the data access port is still blocking. And so what we achieve is not super great, because when we access the database, and here the application, the demo application is only about accessing the database, we are blocking all the time. So we are not making really great usage of reactive. Okay, so let's go a bit further. Now we will change the data access port, and this is much more complex because you must understand that when we do this, we remove JPA, we remove Hibernate, we change the driver as well. So we must use a dedicated driver, and we must adapt all our codes, and it's a lot. So the first thing that we have to do explicitly now is we have to create a schema. Before, the schema was created by Hibernate when Spring Boot started the application, but now we cannot, there is no Hibernate anymore, so we need to provide an explicit schema. The other thing that we need to do is actually to change, I need to do it one by one. So no more Spring Boot Starter JPA, we have a Spring Data R2DBC. No more caching, because caching was on the second level cache of Hibernate. Since we removed Hibernate, we don't cache anymore. We've lost cache, and it might be an issue. Also, we cannot use our regular H2 driver. We must use the R2DBC flavor of it. So a lot of changes. Let's do it anyway. It might take some time to compile. Yes, so this part is still the same, doesn't change anything. Now the person repository, we went from a JPA repository to a reactive sorting repository. On the good side, R2DBC Spring still does the runtime for us, so we don't need to write more. Something I was very, very happy to see this morning is that before Spring Boot 2.5, you actually had to explicitly call the schema and data.SQL SQL script. So this to create the schema, this to populate the database. You have to do it explicitly in your code. With Spring Boot 2.5, it's not necessary anymore. As soon as you've got these enable R2DBC repositories, then it will be handled for you. Of course, it needs to be named schema.sql and data.sql, but otherwise it works. I don't know if I restarted already, so perhaps it might be time to restart the application. And on the person root side, here, as I mentioned before, now I have the body. I don't have the body value because now it requires actually reactive type. So I need to change the flux to a publisher. So I need to write something like this. This is a static method, and otherwise it's still the same. Now, does it still work? Because that's the most important question. Yes, it still works, but no caching anymore. And you can see we are using Netty and not Tomcat anymore. So we are reactive, but we lost caching, which might be a big issue, especially when we are using a real database. So I don't know about you, but it doesn't seem to be super great. Anyway, we can still do better. Here I told you that we want everything in our chain to be reactive, and I'm telling you here everything is reactive. But actually, you shouldn't believe me, and if you have reactive code, you shouldn't believe yourself. You probably need to make sure that it's the truth, that no call is blocking. So in order to do that, there is a super nice library called Blockhound. So you just add the Blockhound library here, and it's part of Project Reactor. And when you start the application, you install Blockhound. And what happens is every time it detects that there is a blocking call, it will throw an exception. And you will see that, hey, here you made you had an issue. So let's restart the application, because now I hope that I don't have any blocking code. It will be very easy to check. Now we can like curl it again, and it still works. So now I'm sure there is no blocking call. I'm very happy. I can go a bit further. Something that I didn't do before, and I think that it deserves to be done, is, hey, I want to return an HTTP code when the entity is not found. So now I've added to my routes, and it will be interesting to see that, hey, I do the repository.findById. And at this point, the mono might contain a value or not contain a value. And I cannot do, if it contains a value, I return the mono. If it doesn't contain the mono, then I return a mono of error with the correct code. I need to use the Reactive API, and the Reactive API in that case is switched if empty. And yeah, it makes a lot of sense. So I do repository.findById, and if the result is empty, I switch to another value. In that case, it will be a mono error of a new response status exception. So at this point, if I do something like that, it returns me, that was the previous version, it returns me nothing. Now, if I restart, the application now, nope, again. If I restart the application now, I should see a 404 error. Let's see if I told you the truth. This one I didn't try this morning. Yes, so here I have 404 error because I returned this status exception. But see, this is the call chain. I cannot use if and else anymore. I just need to use the correct API and chain them together. The next step is, hey, folks, I want to have the cache again, because I had the cache before, and after moving to reactive, I still want to have the cache. So let's do it. And what we can do is I can show you how I change it. So what I did is I forgot it's a Spring project, and so far I didn't have any service layer. So now I fixed it. I have a service layer, and this service layer is actually just like a stupid layer to do what I did before. So I will do it by hand. What I'm doing is, hey, when you find by ID, I get from the cache the ID. If I don't get it, if it's null, then I will like say, hey, it's not found in the cache. Then I will find it by ID and I will put it in the cache. Otherwise, I will return it and wrap it into a mono. Makes a lot of sense to me. And when I do the find all, I will just like find all entities and put them individually in the cache. So let's see how it works. Now I can return every one of them. Oh no, I cannot. Why can't I? Because now Blackhound that I installed before is telling me, hey, you did something very, very wrong. You can see that the reactive stack trace is a bit long. Tell me, no, you did something wrong. You're actually on the caching service on line 36, you're doing something bad. And actually, I am doing something bad. Cache.put is blocking. And Blockhound tells me, hey, that's not the way to do. And actually, if we try with a single call or the single entity, it's the same. Now, of course, the path is located in another place, and we can check here. Now it's on the get. So I'm doing those like blocking calls, and I shouldn't. That's not great. So you can remove Blockhound and ignore it, but then understand that your whole chain won't be reactive. There will be pieces of reactive and pieces of blocking, and you won't leverage the full benefits. So we can, this is a naive way. We should never do that. What we should do again is to use the Reactive API way. And for that, we have something called mono from completion stage. So fortunately, our API has an async flavor. So here we can call cache.getSync. That actually returns, I don't remember, a completion stage. And from this completion stage, we can return a mono. Then let's read it because it's a bit involved. What happens? Here we say do on next. So this will be called only if there is a next, meaning that if the mono is not empty, meaning that we have actually something in the cache. So if we have something in the cache, well, we will write, hey, it's found in the cache. If it's not found in the cache, this won't get executed. But this will be executed if it's empty. So this line will be executed if it's not empty. This line will be executed if it's empty. Now, what we can do is, if it's empty, we will like go to the database. And again, this might return an empty result or not. If it returns an empty result, well, it will be empty and we will have a 404. If it's not empty, then we will call this next line. And the next line says, hey, we will put it into the cache for the next usage. And here, likewise, we call our async API. So now I think it should work. No, I didn't restart it. That's the fun part. I never know if I restarted it or not. No, I restarted, but it doesn't work. So why doesn't it work? Context initialization. I'm too fast. Yes. So I must stop. I restarted it, but the JVM didn't. I had two running instances probably at the same time. It happens sometimes. That's why at the beginning of this demo, I had DevTools, so I didn't want every time to stop the JVM and to restart it, but there were some issues. So now I'm pretty sure that it works. Yes, so now it works. And we can see that person with ID 1 was set in the cache. And we can try it again. And now we see person with ID 1 found in cache. So now we are reading from the cache. We're not using the database anymore, like before. And again, we can put everything into the cache. And let's call like the ID 2. And person with ID 2 was found in the cache. So now we are back with our like all features from before, including caching, and we are fully reactive. So it's time to like have some closing words. And here is a summary. So as I mentioned, why it's probably why it's possible to just use the legacy annotations and just replace WebFlux by WebMVC by WebFlux, you probably shouldn't do it because you might miss a lot of understanding. Because you want your whole blockchain, your own code chains to be reactive, I advise you to use Blockhound. Then you will detect as soon as it happens that something is blocking, like I showed you. Reactive is more work. It's not impossible. It's just a lot of work. And if you are using Kotlin, you can use coroutines, which is even better, but we are using Java. And more importantly, please use reactive because you've got good reasons to do so, and not because others do. Like, don't do microservices because others do. Don't do big data because others do. Don't use reactive because others do. Just use it because you have a business case for it. So make sure that you understand the trade-off. Yes, probably your cloud bill will be slightly lower, but on the opposite side, you need to like have very nice metrics to understand how much more effort in your developer team you are using, because you really must compute both to check if it makes really sense. So thanks a lot for your attention. You can read my blog, you can follow me on Twitter, and more importantly, you can check the code by yourself. So everything is on GitHub, everything that I've shown you here. And if at any chance you are not on our Hazelcast Slack or you didn't get the training, everything is free. Join us, have fun. And now I will be happy to get your questions. So I've got one. How blocking calls are detected, how the library knows of a blocking call, and what is the difference between cache put and cache put async? So that's two different questions. So the easiest one that I can answer is the following, and I lost the questions. So I put them again. I put back the questions. Better questions here. So here you've got, and it depends on the cache provider. In that case, you've got cache.getAsync. It returns a completion stage. So it will be actually asynchronous, and like its name implies. And cache get returns the object directly. So it depends on your provider. Here I'm using Hazelcast. So Hazelcast has async flavors, so it's quite good. If your cache providers have not, then I'm sorry, but you probably need to migrate somehow. The blocking calls, how they are detected, to be honest, I don't remember. I think there is a thread somehow that checks it, but I don't want to tell you anything bad. What I can do is I will check, because it's a very good question. I will check and I will let you know afterwards. That's a great question. I need to check by myself. Other questions? No other questions? Pause.
Hello, Nicolas. Yes, there's no other questions.
There are no other questions. It was a bad talk because I have no questions.
No, I told you before. It happens sometimes. Yes, there's another question now. Hazelcast support Reactor or any other reactive library as well?
So we don't offer a reactive API, reactor or whatever, but as you can see, it's quite easy because we start from the building blocks. We start from completion stage, for example. So every framework supports those basic types anyway. There will also be an adapter to bridge from one world to the other. So we don't support them directly, but the frameworks, the reactive frameworks, they are able to work with what types we return. It's a good question also.
Is there any question? We're waiting a little bit. If not, we will thank to Nicolas. Yes, there's another. Any plan to have Hazelcast plug directly into Reactive API as a cross-cutting common concern?
Again, I'm not sure I understood the question. Can you
chat?
Yes, please. Any plans to have Hazelcast plus directly into Reactive as a cross-cutting? Well, we don't have plans because there are many different stacks and it's a lot of effort. But if you are willing to do that, we will be happy. I will be happy to support you. I mean, Hazelcast is open source, so you can use it, reuse it, fork it if really necessary. But we will be very happy if the community takes something into their own hand and integrate it into any stack. Really. So if you are interested, just join us on the Slack, and yes, I will bring like real engineers to help you.
Okay. Thank you.
Bir şey değil.
Rica ederim. Okay, we don't have another question.
Thanks a lot, folks. I hope that by next year, all this crap will have ended and I will be able to join you in Istanbul and enjoy some nice Turkish foods. And in the meantime, well, stay safe and have a good rest of the conference.
Okay, we are also waiting next time Switzerland chocolates.
Sorry?
We are also waiting Switzerland chocolates when you come to Turkey. Okay, thank you. Bye-bye.